Welcome everyone. In this video, we're going to go over problem number 1, section 3.2, which talks about rotation matrices. So I brought the problem here. However, we're not going to do all of them, but I want to do is A, which is the simplest one probably, then we can do F, and you get a good idea of how to work out the other ones. Now, the rotation matrix in R2, I went over this in the last video, and the proof of that also is cosine theta minus sine theta, cosine theta. That means if you take a vector and multiply it and by that matrix, any given theta, that matrix is gonna rotate that vector counterclockwise. So let's go over this example, see how this works. So again, A theta is pi over 630 degrees, and we have a vector components are 5 and 3. So if you want to write the rotation matrix of pi over 6 is cosine pi over 6. Again, from here, negative sine pi over 6, sine pi over 6, cosine pi over 6. Cosine pi over 6 is cosine of 30 degrees, and that's square root of 3 over 2. Sine pi over 6 is 1/2, and sine pi over 6 is 1/2 again, and cosine pi over 6 is square root of 3 over 2. Now, if you want to rotate this vector, so we take the rotation matrix and multiply it by the components of that vector. So here I did the multiplication for you. So we have square root of 3 over 2 minus 1/2 square root of 3 over 2 times 5, 3. Let's go over this. So again, this is, I write that a 2 by 2 matrix, and this is a 2 by 1 matrix. So if we multiply, we know these are gone, and you're going to have a 2 by 1 matrix, which is right here. So you take square root of 3 over 2 times 5 is 5 square root of 3 over 2. Plus minus 1/2 times 3, negative 1/2 times 3 is negative 3 over 2. So that's the first component. 1/2 times 5 is 5 over 2. Square root of 3 over 2 times 3 is 3 square root of 3 over 2. And of course, you add them. Now, the rotation, the new vector we get by rotating 5, 3 by pi over 6 radians or 30 degrees. These are the new components. Now you can use your calculator and approximately find those numbers 2.8 and 5. Graphically, let's see what happens. This is our original vector. So components are 5 over 3. And we rotate it by pi over 6. And the rotation is going to give us 2.8 and 5. Now, next one I want to do is F. So let me go up, just show it to you. So we're gonna do this one. This one is a little bit different. It says use half angle identities. So let's see how that works. So the best thing to do, this is our theta. So say theta is 1/2 sine inverse of 21 over 29. Then multiply both sides by 2. So 2 theta is this, sine inverse of 21 over 29. Now, if you take sine of both sides, you know sine 2 theta is 21 over 29. You can just graph or draw the triangle. Sine 2 theta, so this is 2 theta. And sine is opposite over hypotenuse, so it's 21 over 29. And find that side also by using the Pythagorean theorem. So if you do that, I did the calculation here, you get 20. Now the half angle formula, if we write it, we can just say sine theta is plus or minus square root of 1 minus cosine 2 theta over 2. And cosine theta is plus or minus square root of 1 plus cosine 2 theta divided by 2. So for sine, that's minus, and for cosine, this is plus. However, we are in quadrant 1, so both sine theta and cosine theta are positive, so we can just drop the negative sign. Now, if you want to find sine theta, using that formula is 1 minus, you go to your triangle, cosine 2 theta is 20 over 29. You can substitute here. And divide by 2. How do you simplify that? You can multiply that fraction numerator and denominator by 29. 29 times 1 is 29, and 29 times 29 over 20 over 29. 29 is canceled. You're left with 20. 29 times 2 is 58. You get square root of 9 over 58. Square root of 9 is just 3, so it's 3 over square root of 58. Cosine, same way, is 1 plus cosine 2 theta. One more time. Cosine 2 theta, we have it here, is 20 over 29, adjacent over hypotenuse. So if you want to simplify, you simplify the same way, and if you do that, you get square root of 49 over 58. Square root of 49 is just 7. So now we have our sine theta and our cosine theta. We can go to the rotation matrix, which was cosine theta minus sine theta, cosine theta, and you substitute. Cosine theta was 7 over square root of 58, and sine theta was 3 over square root of 58. That's pretty straightforward. Now let's rotate that by theta, the vector with the components 5, 3. So rotating, that's pretty straightforward. Now you multiply that matrix by 5, 3, the matrix notation of the vector. And if you do that, 7 over square root of 58 times 5 is 35 over square root of 58. Negative 3 over square root of 58 times 3 is negative 9 over square root of 58. 3 times 5 over square root of 58 is 15 over square root of 58, and 7 over square root of 58 times 3 is 21 over square root of 58. Now you evaluate this, you get the x component is 26 over square root of 58, and the y component is 36 over square root of 58. So the rotation, I just called it theta here. So 5, 3 is going to give us that x component and that y component. Use your calculator. The first one is approximately 3.4, and the second one is 4.7. Graphically, again, this is our original vector. We rotate it by theta, and theta, as you know, it was sine inverse of 1/2 sine inverse of 21 over 29. And you can even find the value of that angle. So then the components of the new vector is going to be 26 over square root of 58 and 36 over square root of 58. I think that's good enough for this video. In the next videos, I'll solve more problems, homework problems. Thank you for watching, and I'll see you in my next video.